Alright, to multiply and simplify this expression, what I'm first going to do is apply the power of a product and quotient with this exponent 5 right here. And what that will look like is every factor will get this exponent. So the 5 to the 5th, this x to the 3rd gets raised to the 5th, and everything in the denominator also gets raised to the 5th. And then we obviously still have this second fraction over here. Alright, and then I'm going to do some cleanup here. I'm going to clean up these two factors right here by multiplying their exponents together because the power of a power. And then I'm going to deal with this negative exponent in this factor over here by moving this factor up into the numerator. What I'm going to do now is just multiply these two fractions together. You multiply straight across. So in the numerators, what I'm going to get is I have this 2 to the 3rd times 5 to the 5th. And then I'm going to put the x's together to get x to the 22nd and y to the 6th. In the denominator, I'll just have 2 to the 5th, 5 squared, and y to the 45th. I have two options at this point. I'm first going to attack this by applying the quotient property of exponential expressions by subtracting the exponents of each of these like factors and subtracting the exponents from each other. So 2 to the 3rd divided by 2 to the 5th will give me a 2 to the negative 2. The 5 to the 5th divided by the 5 squared is a 5 to the 3rd. The x to the 22nd stays by itself. And then y to the 6th divided by y to the 45th is y to the negative 39th. The last step then is simply to throw the factors that have negative exponents in the denominator. So I will have a 5 to the 3rd times x to the 22nd over 2 squared times y to the 39th. That would be my final answer. One way to clean that up would just be to evaluate 5 to the 3rd, which is 125 x to the 22nd over 4 y to the 39th. I'm now going to investigate another way of attacking this problem from a couple steps ago. And it's instead of subtracting, I can think of canceling like factors. So what I'm going to do is go from this step right here and apply canceling common factors instead of by subtracting the exponents from each other. Okay, so in this case I'm going to think about this common factors of 2. I'm going to cancel 3 2's in the numerator and in the denominator. I'm going to cancel 2 of these factors of 5 in the denominator and numerator. And then I'm going to cancel 6 of the y's in both of these. Being left with 5 to the 3rd times x to the 22nd on top, and 2 squared, and y to the 39th on bottom. Either one of the two methods I've just done are exactly the same and both correct. They're just two different ways of tackling the same problem. Hope that helps.